Hi guys, tonight we're going to take a look at compound interest. And compound interest is something that's used when you get interest on an account. It's sometimes it's used when you're paying interest, so such as a mortgage or a credit card. And so we're going to do this in two parts, and so today is part one. So let's go ahead and get started. Okay, so once in a while you hear about people winning the lottery. Not me, but you hear about it. The winnings can be several millions of dollars, and the big money winners are usually paid in annual installments for about 20 years, while some smaller prizes are awarded in a matter of weeks. Your uncle gave you a lottery ticket on your 18th birthday, because you have to be 18 to play the lottery, and you won. In the lottery payoff scheme, you have two payoff choices. So the first option is to receive a single $20,000 payment and use the bank to deposit your money in. And the bank has a 10-year certificate of deposit, which means you have to leave it there for 10 years, and it's paying an 8% interest rate. Your second option is to receive no money now and a single $40,000 payment 10 years from now. So in this case, you have to wait 10 years to get your $40,000. So we're going to take a look at option one. Is option one or option two better for you when choosing what to do with your lottery winnings? So before we do that, let's take a look at what our values for A and B are, and I'm going to write them over here. Our start is how much money you won, and that's $20,000. And our growth factor is 100% plus the 8%. And as a decimal, our growth factor is 1.08. And keep in mind, our growth factor and our common ratio are the same thing. So if we're going to write a now next for this, our start is 20,000. And to get from one term to the next, our next equals now times 1.08. So number two, write an explicit equation. An explicit always means y equals. The now next, this one is a recursive. It's just how do I get from one term to the next. Explicit is always in y equals. So before we do that, we want to define our variables. So what is x measuring? In this case, x is measuring the number of years. And y is our account balance. So you have to leave that in there for a certain number of years, and how much money will you have. At the end of each year, you could figure it out, or at the end of 10 years. So if we're going to write an explicit equation, we get y equals 20,000, because that's our start, times, and our growth factor, our common ratio, is 1.08, and we're going to raise that to the power of x. So now we're going to take a look at, we're going to use that equation to figure out how much money you would receive at the end of year one, or how much money would be in your account at the end of year one, at the end of year two, and the end of year three, and then go ahead and see, okay, well, how much would it be after 10 years? So in year one, since x is the number of years, this is where our x value equals 1. So to put it in our equation, y equals 20,000 times 1.08 to the first power, and that comes out to be $21,600. So including interest in your initial $20,000 at the end of the first year, you would have $21,600. Go ahead and do year 2 and 3. Then pause the video and then check your answers. Okay, year 2, that's when x equals 2. That's the number of years. And year 3 is when x equals 3. And again, what we're doing is just taking out this x, we're replacing it with 2, this variable, and replacing it with 3. And so after 2 years, interest and your original $20,000 is $23,328. And then at year 3, you have $25,194 and 24 cents. So let's take a look and see, okay, well, I've left it in there, you've left it in there for 10 years, because certificates of deposit, when you leave it in there, you leave it in there. If it's a 10-year CD, certificate of deposit, you leave it in there for 10 years. So in this case, our x equals 10, so we're doing the same thing. We started out with $20,000. Our growth factor, our common ratio, is 1.08, and we're raising that to the 10th power. And so when we do the math, we get $43,178.50. So your original $40,000 in interest, compounded interest, you gained an additional $3,178. Oh, I take that back. No, you didn't. You gained another $20,178.50, leaving it in there for 10 years. Okay, so last question. Which option should you take and why? Well, let's take a look at the numbers. Option 1, after 10 years, your $20,000 turned into $43,178.50. And option 2, your $20,000 after 10 years, taking your lump sum, you would only end up with $40,000. So clearly, option 1 is the better option because you earn about $3,178.50 more than you would if you chose option 2. Okay, so here are our video questions. Multiple choice number 1 is asking you, what is the growth factor, the b value, used in this exponential equation up here? So if we had to calculate b, that's what it's asking. What is b equal to? It's paying 4.75 annual interest rate. Question number 2, find the account balance after 25 years with the interest compounded yearly. So you need to write your y equals equation, y equals a times b to the x. What is a equal to? What is b equal to? And what is x equal to? And then make sure you enter your answer on the Google form as dollars and cents, and money is always rounded to the hundredths place. That's 2 places after the decimal. Be sure to enter your answers on the Google form.